Carbonomics, the wonderful economy of the soil. And what I'm going to do is I'm going to compare the soil to the economy of a country. But before I get started, just a little bit of background on where we're at. We're here at Blade, Nebraska. Basically, it's almost in the exact center of the 48 continental United States. So we're kind of right in the middle of everything. It's a good location for being able to do that. Our farming background is we've been no-tilling there in south central Nebraska for 25 plus years. We're about 2/3 of our land is dry land and about 1/3 of it is irrigated. Most of it pivots, a little bit of gravity, but mostly pivots. Traditionally, we've been in a corn, bean, cereal type rotation, but since we've been doing cover crops, we've diversified, and now we're growing rye and triticale and oats and barley and vetch and sunflowers and buckwheat and kind of weird things like that. So we have an advantage because we can sell that through the seed company, and it's really allowed us to diversify what we grow in our farm. We started green cover seed in 2009, and since then it has grown fairly quickly. This is a picture I just took off of Google Earth that's fairly current. Basically, in 2011, everything you see here was all farm ground, and this is our main building, and then all the bins and other storage buildings that we built. So it's grown pretty quickly. We've used cover crops for the last 8 years since we did a SARE project and really saw what cover crops could do for us. We decided to take the plunge into helping other people do the same thing. So I want to, this is kind of cool. We were very honored when about 1.5 years ago, Rob Meyer from SARE contacted me to see if we'd be part of a video project that the Soil Health Institute commissioned a film company basically to make a soil health documentary. And we'll be showing, there's a couple of short clips that we'll be showing here throughout the conference. The more feature documentary has not been released yet. That's due to come out either at the end of this year or first part of next year. So they sent this film crew out, and this is a beautiful October day. Okay, just a beautiful day. They wanted to get some footage because we were harvesting corn. We were out in the field picking corn, and we wanted to have the air seeder out there, so we had some good video footage of the combine and the air seeder both running in the same field to emphasize that we want to always have something growing. So the video crew came out. They brought in this really cool drone, which takes high definition, really cool video. So I just want to show you this because, we were feeling, really pretty good about this. So go ahead and roll the video, Caleb. Like I say, it's a beautiful October day. I had the guys go hook up the air seeder, and I jumped in. And going down the road thinking, man, this is really going to be cool. We're going to be movie stars. We're going to be in this documentary. And I got this big 4-wheel drive tractor, and things just couldn't hardly get any better on a day like this. And so just about the time when you start thinking like that, yeah, about the time you start thinking like that, that's what happens. Now, I would guess that almost everybody in here has done something like this, but I would guess almost no one has it captured on high definition drone footage. Okay? And you got to be careful because pride goeth before a fail. And so that's, I watch that all the time because it is humbling. But it also is, God really blessed. That could have been a whole lot worse. My mom and dad sitting back here, they laugh about that. And I said, you wouldn't have been laughing if it had went the other way. It would have went right through your house. So I like to start with that because it's kind of funny. So what I want to do here this morning to kind of get us started out is I want to take one of the most complex systems in the world, and it's this whole system of soil. And when you study the soil, it's incredibly complex. And it's really hard to understand because there's all these things going on. It's much more than just dirt. And the more we study it, the less it seems like we know. So it's a very, very complex, intricate system. And I want to try to explain this to you or give you some perspective on this by comparing it to another extremely complex, very intricate system. and that's the economy of a country. And the reason that I think this is a good comparison, a good word picture, if you will, is because we all understand an economy because we live in it every day. You know, we're buyers, we're sellers, we operate within an economy every day. You know, there's cartoons about it. You know, relax, my broker says the economy will bounce back. The bum on the street says, I am your broker. You know, so we can laugh about economics, there's cartoons about it. We understand it inherently, whether we know it or not, because we live in it. And basically, if you have forgotten everything from when you took econ class in high school or college, which most of us probably did take it and probably have forgotten it, there's 7 basic keys to a healthy economy. I'm going to quickly go through each of these just to give you a brief overview, and then we're going to look at how these apply to our soil systems, because we don't often think about all these things in comparison to the soil, but they're there. So first of all, in a healthy economy, you have to have supply. You can't have an economy if somebody isn't making or growing something. You got to have something that can be sold. And economies are strongest when a high percentage of all the entities within the economy are producing something. This is the basis of an economy. You have to produce something. Secondly, you have to have somebody that wants to buy it. There's no good in producing stuff if you can't sell it. Just ask corn farmers, right, Scott? You know, if you have too much of something, so you have to have demand. And again, economies are strongest when the high percentage of everybody in the economy are wanting something as well as producing something. And diversity is very important. And you'll see this phrase come up several times in this talk, because economies will not be strong if we're only producing one thing, or if we're only wanting to buy one thing. That makes a very, very unstable economy, and it's subject to fail. So we want a lot of diversity within the economy. Thirdly, currency is very important in an economy because currency allows the transactions between buyers and sellers to happen very easily, very efficiently. You know, you can go to any store in town here, and you can go buy something, and you can pay cash. You know, most places may still let you write a check, or you can use a credit card. That currency allows those transactions to happen. And currency, to really work well, has to be universally desired by everybody, so everybody has to accept it, and it has to have different forms, and it has to flow easily throughout the economy. Capital within an economy is simply when you have excess currency, you can turn that into capital. You can store it, you can invest it, you can purchase assets through it. Capital is what gives us the ability to grow our economies. And then energy and resources are very important for an economy as well. Energy drives the system, but it's often very expensive. And resources provide the base in which we can grow and expand our economies. Infrastructure allows us to grow our economies beyond just the subsistence level. In other words, if we're going to grow more food than what we just need for our own families, we need some infrastructure in place to be able to make that happen. And the 2 most important ones that we'll talk about are communication and transportation. Whoops. And then finally, defense and protection. We need to defend and protect our economy because there will always be those who want to consume without producing. And defense requires investments of capital. Defense requires investments of capital. Okay, so there's the 7 keys to a healthy economy, and we're going to look at how these 7 keys apply to the soil and your soil system and your own farming operation. So, first of all, the soil economy, it's all based on solar energy. Okay, our economy of the soil, what you and I do as producers, it's all about solar energy. Really, you know, I've heard people say that as farmers, really all we're doing is we're capturing sunlight and we're turning it into some sort of product that we can sell and market. So the soil economy is based on solar energy, and the 3 main players within this are the plants, that's obvious, the soil, of course, but the one that gets left out a lot is the animals or the biology. And when we think of animals, you know, we often think of the large animals like cattle or sheep or hogs or something like that. And while they are important, what we're going to focus mainly on are the little animals, the tiny critters, the microbiology. And we'll talk extensively about that because in a healthy functioning economy of the soil, you need all 3 of these to be playing active roles within the economy. And too often what we've done is we've left these guys behind. And we'll talk about that here. So first of all, on the supply side, what do each of these things bring to the table? The plants, the soil, and the animals, what do they supply? What do they produce within the economy? Well, quite simply, plants produce carbon. And plants produce carbon. If you remember nothing else from this whole time, just remember that. Photosynthesis, you all studied this in high school or college. Photosynthesis is the most important chemical formula in the entire world. It's the basis of our whole existence because it's where we get our food. But plants are able to take carbon dioxide, which is considered a waste product, and some people are saying there's too much of it, greenhouse gases. So we're taking a waste product, plants combine that with water, they use the energy from the sun, they use chlorophyll that are in the plant cells, and they convert that into very, very useful products. C6H12O6 is a glucose sugar, and then O2 is oxygen. Okay, so they're taking a waste product in water, and they're turning it into sugar and oxygen, both things that we want and need very badly because we all need to breathe, and we all need to eat, and we all like sugar. And this carbon molecule right here, the C6 on this glucose molecule, we're going to kind of follow that through the system to some extent here, and we'll look to see how that carbon is so important to the entire system and how the carbon really drives the whole system. And that's why the title of this talk is Carbonomics, because the carbon is what drives the economy. So plants produce carbon through photosynthesis. Number two, what does the soil provide? Well, soil provides nutrients, mainly through the form of minerals. You can see the chart there on the screen has the main minerals or the main nutrients that plants need. Now ignore nitrogen at first because the soil is not providing nitrogen, but most of the rest of these are being provided by the soil. Through the mineral makeup of the soil can provide the nutrients that the plants need. It also provides a habitat for the roots and the biology because plant roots have to have a place to grow and the biology has to have a place to live. And it provides that habitat for both the plants and the biology. And also a very important function is that soil provides water storage. And the better your soil, the more water you can store. Nathan demonstrated that out there. You can't store it if you can't get it in, but you also can't store it if your soils are all worn out. So healthy soils provide excellent water storage. And then thirdly, what do the biology provide? Well, they provide a lot of the nutrients, both through production, as we'll see through nitrogen fixation, but also they play a key role in making the soil nutrients, the soil minerals, they make them available for the plants. Because the way God created the system, He put the minerals in the soils, but the plants can't access most of those minerals directly. Plant roots can't get to most of those minerals in the soil. The biology can, and then the biology makes it available to the plants. They also play key roles in providing defense and protection of this whole ecosystem, as we'll look at as we move forward here. On the demand side, that's what each of these three entities is producing. On the demand side, plants need nutrients, plants need water. That's very obvious. We know that very well. But plants also need services like protection and support, the ability to communicate with each other. So we'll see how that demand is met within the system. Soil needs carbon. Soil without carbon is very light-colored, and it's very unproductive. If you don't have carbon, you don't have organic matter, you're not going to have a very productive soil. Plants also need services, particularly, or soil also needs services like protection, because the soil can do wonderful things, but the one thing soil cannot do is protect itself. It cannot cover itself. It has to be protected. It has to be defended, because if we don't, we're going to see exactly what we saw out there. We're going to see a lot of erosion. And once it's gone, it's gone. So soil needs to be protected. The biology, they have fairly simple needs. They're living organisms like you and I, and they basically need food and they need a place to live. You give them those things, they're going to be pretty happy. They're going to do their job. They're going to give you a lot in return if you provide them the right environment and the right food sources. So that's what everything produces, and that's what everything needs. And just as in a human economy, one of the leading indicators of a strong economy is low unemployment. Because when an economy is really rolling, everybody's got a job and everybody's doing something. And when people have a job and they're making money, they're going to spend that money. And that's what makes an economy work. Everybody's producing something, everybody's buying something. And it's the same way in our soil system. The strongest soils, the strongest soil economies are when everybody is both producing and consuming. And it's strongest when everybody is doing their work. And diversity is very important again. We don't want to have just all one kind of plant. We don't want to have all just one kind of biology. We want the diversity because that gives us the most resiliency and the strongest system. Now what has happened, and as you saw in that little video that we started out with, the Healing the Land video, what we've done as industrial agriculture is when we externally provide the plant with everything that it needs from the outside, when we put it on from a jug or from a tank or something like that, when we provide these external inputs, we weaken the economy. And I call it agricultural welfare because from an economic sense, that's really what we're doing. Welfare is when somebody can't do it for themselves or won't do it for themselves, so you give them a handout. You provide it for them. And that's really essentially what we're doing in our agricultural system to a large extent. And when I say this, we're guilty of doing it ourselves. Okay? We're trying to get away from providing welfare to our crops, but it's hard. It's difficult. And the reason that we have to do that is because we've broken the economy. We aren't allowing it to work the way God designed it to work because we've largely ignored the biology. We've taken the biology out of the system. We've essentially put them on the unemployment line, and then we have to step in and rescue the plants because they start looking yellow. They start looking sick. And we can't afford to let them not be productive, so we have to step in with the welfare. Abraham Lincoln said, "You cannot help men permanently by doing for them what they could and should do for themselves." Okay, now he's not saying we should never help other people. We should. We need to. We're called to. That's part of our responsibility. But he says you can't help them permanently when you continue to do for them what they could and should do for themselves. And I would say the same thing applies to our soil. We're not going to build up our soils. We're not going to make them as productive as they could be if we're continually doing for that system, for that economy, what it could and should do for itself. And you're going to hear from a lot of other people throughout the course of the next 2 days that are going to bring a lot of this from the theoretical that I'm talking about into the practical, and they'll talk about how people are actually doing this. So what we need to do is we need to allow the system to work the way it was created to work, and mainly by getting the biology back involved. What can we do to bring the biology back into our systems and get the economy working the way it is? Because the more active our biology is, the less welfare we have to provide. The better biology that we have, the less fertilizer inputs I have to put on. The better my biological activity is, the less I have to come in with a rescue treatment of a fungicide or a herbicide or any of these types of things. Can we get completely away from it? Yes, we can, because there are people doing it. Will most of us get completely away from it? Probably not, but we can sure get rid of a lot of the welfare that we're providing. So that's our goal on our own farm, is to reduce the amount of inputs, to reduce the amount of welfare that we're having to give without reducing the amount of money that we're making, because none of this makes any sense, none of this matters if we don't make a profit. So the goal is to do this and still maintain profitability. And again, some of the other speakers over the next 2 days are going to be talking about those very subjects. Okay, so that's the supply and the demand side and what happens and how things work. Currency, again, currency is important because it allows goods and services to be exchanged very efficiently. And, back when people first started trading with each other, they would use goods like cattle or beads or shells or something. And it was difficult because there was no known value to that. It was more of a barter type system. And it works, but it's not nearly as efficient. It's not nearly as fast. as when you have universally accepted currencies that I can go anywhere and we know what the value of this is. And so within our soil system, that's important too. And in this soil system, in this soil economy, the currency is carbon. And carbon, if you think about it in terms of currency, it's the perfect currency. Okay, and I'm gonna walk you through this of how important this is, and the reason I want you to really think about this is because we all know the value of having money. When you have money, you know, when you got a fistful of dollars, you can go out and purchase things. And it's the same way in the soil system. When your soil, when your plants have carbon, they can go out and buy things within this economy. And so carbon is extremely important. And again, the carbon is right here. It's coming from photosynthesis. And think about this. You know, you probably all told your kids, hey, money doesn't grow on trees, right? Well, you know what? In our soil system, it kind of does. It grows on trees, and it grows on corn plants, and it grows on Bermuda grass. We are growing our own currency. How cool is that, that we get to participate in an economy when we can actually print our own money, essentially? That's essentially what we're doing. When we plant plants, and we're pulling CO2 out of the atmosphere, and we're putting it into the system, we're essentially printing our own money. It's very, very cool, and we're very blessed to be able to do that. Carbon is the one thing that we don't have to add out of a jug because we can pull it out of the atmosphere. So look how carbon functions as a currency. It's important because it allows goods and services to be exchanged more efficiently within the soil system. And so what happens is you see the plants making carbon payments to the biology, and through the form of root exudates, okay, because as the plants produce through photosynthesis, it produces that glucose. It's estimated, I've heard experts say, anywhere from 40 to as much as 60% of the carbon, the glucose that a plant produces, as much as half of that is not used in the plant itself. It's not used in the roots or to make the leaves grow. As much as half of that is leaked out through the root system and is traded to the soil biology in exchange for services. That's a lot. You know, giving away half your income, that's almost like taxes, isn't it? But they're getting something back for it. They're making these carbon payments through the root exudates, and then the biology provides services back to the plants, such as sourcing nutrients, providing nutrients, delivery of nutrients, protection, things like that. So it's a two-way street. It's commerce, and carbon is the currency that makes it all happen. So the more carbon that you have in your system, the more active your economy is. It's essentially like having stronger cash flow when you have more carbon within your system. Carbon is essential to all life. You and I are 19% carbon. Carbon can form over 10 million different chemical compounds that are very important, as we'll see, that, you know, we can't have carbon just in one form. It has to be in multiple forms. Carbon is the most important, but it's also the most overlooked of all plant nutrients. It's the number one thing that your plants need, but how often do you sit down and you make a carbon plan of how much carbon are we going to have? And carbon is the main food source for soil biology, and we almost never think about that. How are we going to feed all of the biology that we have under the ground? And you talk about, you know, making sure you have a forage chain to feed your livestock, but you need to be thinking about the forage chain, the carbon chain, the food chain for all of the livestock you have below the ground. Because in a good, healthy, functioning soil, there's the equivalent of 2 or 3 full-grown cattle underneath the soil as well with all your biology. When you have increased soil carbon currency, when you have more carbon in your system, it normalizes soil pH. So if you have either high or low pHs, increased organic matter will help buffer that, and you'll be able to grow things in a higher or low pH soil that you normally wouldn't if you have excess carbon. It increases cation exchange capacity, it increases the availability of all of these good nutrients, and it reduces the availability of the ones that can get too high on us. Sodium, aluminum, toxicity issues tend to go away in higher organic matter higher carbon soils. So it's not only doing good things with the exchange between the biology, but it's doing good things just in the physical components, the chemistry of the soil as well, in that it makes the good things more available, and it tends to reduce the availability of things that can have toxic levels. Carbon is a perfect currency because look at this. It can be collected through photosynthesis. It can be spent when it's traded to soil organisms. It can be saved through soil organic matter. We'll talk about that in just a second. And it's desired by all members of the economy. Everybody in this economy wants carbon. Carbon has different states. It can exist in the gaseous form, which is CO2, which is every time we breathe out, we're putting CO2 back into the atmosphere. And I'm going to say that that's kind of like the credit card state, because that's just, CO2 in the atmosphere is virtually unlimited, right? Just like credit cards. That's just an unlimited source of income, right? You just keep running them through. But it's a different form. Liquid is the type of carbon that moves up and down through plants. Liquid carbon, we don't think very often as carbon being in the liquid form, but liquid carbon moves up and down through the plants, and that's how it gets from where it's photosynthesizing in the leaves. That's how it gets down to the soil organisms in the liquid form. And that's kind of like cash. That's the most liquid form, pardon the pun, liquid cash, liquid carbon. It moves very easily, and that's what's actually transferred to the organisms. And then solid carbon, which is probably what we're most familiar with, in solid materials, where the 19% carbon that we have in us is solid. Plants have a lot of solid carbon. That's more of your long-term storage, like buying a treasury bond or something like that. It's more of a longer-term investment. But these carbon very easily changes from one state to another. And if you study the whole carbon cycle, we don't have time to do that, but you will see carbon moving between these three states very easily, just as when you earn money, it can transfer between these different states as well. So carbon is the perfect currency that drives our system. And then the great thing is when you have excess carbon, when you have more than you need to spend, you can start saving it. Just like when you earn more cash than what you spend, you can actually start a savings account. When you earn more than what you spend, you can start investing in equipment, or you can buy land. Now, sometimes we borrow that, but we still have to pay it back. So in the long run, we have to make more than we spend if we're ever going to save anything, unless you're the government, and then you just keep spending, I guess. I don't know how that's all going to work. But capital can only happen, you can only gain capital if you have excess currency. That's just an economic principle that you ignore at your own peril. And so it's the same way within the soil. We increase our capital when we have excess carbon. Walt Davis, many of you have heard Walt speak, a rancher from Oklahoma. He speaks extensively about biological capital. And I just want to kind of hit some of the highlights of what Walt has to say. Biological capital, and again, this is in large part, carbon, organic matter. Biological carbon or capital has long-term effects on having biodiversity, having a diverse number of organisms in your soil. It's soil with high organic matter content. It's diverse and healthy populations of plants and animals both in and on the soil. It's wealth in the truest form. Biological capital is vital not only to agriculture, but to society as a whole. And when our biological capital in our soils is high, productivity and stability will be high. Pest organisms will still be present, but they're going to be in concentrations low enough to where they're not going to hit economic thresholds. And the ecological processes, the water cycle, nutrient cycle, energy flow, all function properly when you have high biological capital. And that's strongly tied, to your organic matter levels of your soil. Now, when we talk about the carbon capital within the soil, we're talking primarily about organic matter, because that's where our long-term excess carbon can go to be stored. Organic matter and humus is stored and a saved carbon currency, and we need that for growth and stability. And we could talk this whole conference just on how important, how valuable soil organic matter is. We don't have time to do that. But you've all seen it. When you have higher organic matter levels on a particular field, it's always going to be more productive. It's going to be the last one to show signs of a drought. It's going to be the first one to recover. It's going to be the least likely to get hit by diseases or pests because it has the high organic matter levels, is able to buffer a lot of those things. And what we see is a direct correlation here. When you have an economy of a country where you have a lot of capital, and for the most part, the United States is a very capital-rich economy. It's productive, it's stable, it's resilient, and it's very efficient in how it produces things. And it's the same way with your high organic matter soils. They're going to be productive, they're going to be stable, they're going to be resilient, and they're going to be very efficient. It's stunning how directly correlated these things are between a capital-rich economy and a high organic matter soil. They're always going to be more productive, and they're always going to be more resilient. Ratan Lal, who is with Ohio State University now, he says, soil organic matter generates and regulates every ecosystem service that sustains life on Earth. That's a pretty bold statement. And if we want to sustain these services that sustains life on Earth, we need to be farming in such a way that we're increasing our soil organic matter and not decreasing it. And I talk all the time to farmers up in my area, you know, that's mainly just a straight corn soybean rotation. You know, we're never going to increase soil organic matter levels in a corn soybean rotation because we aren't putting enough capital, enough carbon back into the system to grow that. It's kind of like living, if you're not using cover crops to add additional carbon into your system, it's kind of like living paycheck to paycheck, because the crops are going to produce just enough carbon for its own needs, but not more for the soil in order to build that organic matter levels. Carbon capital can't be increased without an excess of cash income. You know, so soil organic matter can't be increased unless you have excess soil carbon. And most rotations, and this is annual cropping rotations, perennials are a little bit different. Jeff Goodwin's going to be talking about perennials here next. But in an annual cropping rotation, it is very difficult to build organic matter levels without the use of cover crops or some other type of intercropping type system that is more than just the cash crops that we're taking off. Again, we could talk about that forever, but we need to move on. Next, energy and resources. Again, you know, I said that our currency literally grows on trees and plants, but our energy is also free. Now, you would think that as farmers we should be making all kinds of money because, you know, our energy is free from the sun, solar energy. Our currency, we can literally print our own currency. We should be making more money. I haven't quite figured that part out yet. But the economy, the plant economy is powered from the sun. The solar energy of the sun drives this system. And the good news is that all we have to do is go out and plant seeds, and we can grow our own solar collectors. They're much, much cheaper and much easier to install than man-made solar collectors. So we can collect all of this solar energy, and a healthy soil economy should not need significant purchased energy inputs. And when you look at, you know, your bottom line for the year, and you look at how much money you spent on energy, you know, likely we're going to look at diesel fuel, gasoline, and electricity, propane, things like that. But really, for most of us, most farmers, they miss the number one energy input on their entire farming operation, and that's the amount of energy that it takes to produce nitrogen fertilizer. And this is a picture of a nitrogen factory here, if you will. And we'll talk about how that all works and how we can get around that. But the number one energy cost in agriculture is not diesel fuel, it's nitrogen fertilizer, because of how much energy it takes to produce that. And it's kind of a hidden cost because we look at it as a fertility cost, not as an energy cost. But it really, the majority of that nitrogen bill that you're paying is for the energy that it took to produce it. And so I say that a healthy soil economy should not require significant purchased energy inputs above and beyond the solar energy that we get from free. And we know that because there were very, very productive and healthy ecosystems that existed for thousands of years before we ever got here. And nobody was going out and putting fertilizer on or using diesel fuel to do anything then. So a natural functioning economy, soil economy does not need outside energy inputs. Dwayne Beck at the Dakota Lakes Research Farm up in South Dakota, they have set a goal for their farm to be energy neutral, and I'm not exact. I can't remember what year. If it's 20 or 25 years, they basically want to be energy neutral, or not be. They'll produce as much energy as what they're buying. And the way that they're going to do that, number one, is they got to cut down on how much nitrogen that they're using. Number two, they will grow crops like sunflowers and canola that they can press oil out of and burn in their diesel engines to offset other energy needs. So that's their goal. It's a very ambitious goal to basically be energy neutral within their own operation. But it's very doable too, because again, most of our energy comes from the sun, and that is free. Plant resources, we talked about the resources that are needed to build our economy to make it strong. The number one resource that we need is carbon. We've already talked a lot about that, so I'm not going to talk further about that. But number two is nitrogen. Nitrogen is number two, but it's the number one thing that we talk about. It's the number one thing that we spend money on. There are billions of dollars every year spent on nitrogen. Now, what's very interesting is all of this carbon that we get. This is a pie chart of the atmosphere. All of the carbon, this little black line, 0.03 something percent of our atmosphere is carbon dioxide. And that's where plants are pulling all of the carbon that they need. There's no shortage of CO2, even though it's a tiny, tiny fraction of the atmosphere. But plants can get all the carbon that they need out of the atmosphere from that tiny little sliver. Nitrogen, and it doesn't cost us any money. You don't have to pay for CO2. In fact, hopefully someday they'll pay us to take the CO2 out of the atmosphere. Nitrogen, on the other hand, is the red block. 76.55% of our atmosphere is nitrogen. So it's all around us. We're surrounded by nitrogen, yet we spend billions of dollars to buy it. What's up with that? Well, there's good news and bad news, okay? The good news is, well, first of all, nitrogen is held in a dinitrogen state, and this gets into chemistry that I'm not necessarily real expert on, but there's a triple bond. The nitrogen is held, there's two nitrogen molecules bound together with this triple covalent bond. Very, very strongly held to each other. Now the good news is, because of that strong bond, that nitrogen molecule is inert. And that's good, because if it wasn't, we'd all be dead. Because you cannot breathe 76% nitrogen and stay alive if that nitrogen wasn't in an inert form. We breathe it in, we breathe it out. It does nothing to our system. If you breathe in some anhydrous ammonia, that's going to do something to you, and it's not going to be good. That's not inert, okay? So nitrogen being bound with this triple bond is very, very strongly held. It does not interact with anything in our bodies, so it's just an in and an out thing. That's the good news. We're not dead. The bad news is, just as it won't react with anything in our bodies, plants cannot use that either. All of the nitrogen surrounding plants, 76% in the atmosphere, does a plant absolutely no good whatsoever, because the plants cannot break that triple bond and get that nitrogen molecule pulled apart to where they can utilize it either. So we end up having to spend a lot of money. You know, we can commercially break this bond, but it's extremely energy intensive, okay? And what happens is when nitrogen gets fixed or made plant available, it's combined with hydrogen or oxygen, and there's a chemical formula there of how you can take that dinitrogen and you can add nitrogen and make ammonia and ammonium. You can do that, and largely we figured out how to do that during World War II, because they discovered that you know, these types of inert nitrogen is very explosive. And so it was largely a bomb making. They used it to make explosives for World War II. After the war, they used that same technology to produce commercial nitrogen in factories like this. And so we can do that, but it requires a lot of energy to do. They're getting the nitrogen from free because it's in the atmosphere all around us. What you're paying for is the energy that it takes to break that bond. Very, very energy-intensive process because nitrogen is held very tightly. But the good news is, it doesn't have to be that way, because what we can't do as people, what plants can't do as plants, little tiny bacteria say, no problem, I can do that. And so there is a specific class of plants called legumes. You're all familiar with legumes. And a lot of times people will say, well, plant a legume plant. It can make its own nitrogen. That's not true. Plants can't do anything with that dinitrogen molecule, but they will allow bacteria called rhizobia to form colonies on their roots. They look like this, these little nodules on the roots. Here's a close-up of one cut apart. Essentially what these are, that's millions and millions of these little rhizobia bacteria that have essentially built a nitrogen factory on the plant roots. And these bacteria can break that triple bond, that triple covalent bond that takes lots of energy for us to do as humans. They can break that down. I don't understand how they do it. If you want to know, you got to find somebody smarter than me to explain how the bacteria are doing that. But they're breaking that apart, and they can fix that into a form that the plants can use. But guess what? They don't do that for free. There's no such thing as a free lunch in the soil economy. These guys can do wonderful things. They can break nitrogen bonds that plants can't do. But you know what they can't do? They can't produce their own food. Plants can produce their own food through photosynthesis. Biology cannot. So this biology only works if the plant is willing to pay for it. And the payment, what's the currency? It's carbon. So these bacteria will build these nitrogen-fixing factories on these plant roots, and they say, I will provide you with nitrogen if you pay me in carbon. And the plant says, that's a good investment for me. And so a soybean, a good healthy crop of soybeans, can produce as much as 500 to 600 pounds of nitrogen through their association with the bacteria. The bacteria are producing that much nitrogen for the soybean plant in a highly, highly productive field of soybeans. 500 to 600 pounds, that's a lot of nitrogen that are being fixed by the bacteria, and the plants are trading carbon to get that nitrogen back. Pretty cool. Pretty cool how that works. Now, it's not just limited to legumes, though. As farmers, we have been trained with the mindset that only works with legumes. You got to have the right legume, and you have to have the right bacteria. And each one requires a specific type of bacteria. If you have questions about that, Charlie Robbins is right here. He's with Vision Biologicals here, right in Wichita Falls. And he can talk to you more about rhizobia. But it's not limited just to legumes. This is pretty cool here too. There are other organisms within the soil that can produce nitrogen that aren't limited just to legumes. So you have things like Azospirillum, Azotobacter, organisms like this that can fix nitrogen. They will take the nitrogen out of the atmosphere, break it apart, make it available to plants, not at nearly as high a levels as what rhizobia does, but these guys will produce 20, 30, 40 pounds of nitrogen per acre, which is not enough to produce a big grain crop. But think about what 20, 30, 40 pounds of nitrogen does for a native grass stand. Or think of what that could do for a cover crop when you're not fertilizing it. Now the thing about these guys, they still can't produce their own food, so they have to associate with a plant. They still have to associate with a plant in order to get their food source, the carbon. So they can work with a corn plant, they can work with a sorghum plant, they can work with a wheat plant. They're not all that picky who they sell their nitrogen to. They just have to get carbon back from somebody so they can stay alive. The other thing about these guys is that they will not do this if there's excess nitrogen in the soil. And the reason that they won't do it, they would be happy to fix nitrogen, but the plant is not willing to pay for something if it can get it for free. And that makes sense. I mean, would you pay for something if you can get it for free? If you can get the farmer to give you a handout, are you going to spend your carbon money to go buy it from the soil system? No. So when we fertilize, these things just go away. These are non-factors in a fertilized system. And again, 20, 30, 40 pounds may not be enough to grow a 200 bushel corn crop, but in a system where we're growing a lot of legumes, we have very healthy functioning ecosystems, and we don't add fertility, we don't add commercial nitrogen, these things will jump in and give us that extra kick to get us up and over the top. In a cover crop situation, in native range type situations, where we're not putting nitrogen fertility on, these things can make a big difference. So again, there's lots of different ways that our system can get the nitrogen that it needs without having to spend a lot of money doing it. Other mineral resources, we've talked about carbon and nitrogen. This is kind of a cool chart I found online. It's all of the 16 essential elements required by plants. Carbon, hydrogen, oxygen come from the atmosphere. N, P, and K are kind of the main macronutrients, and then we've got all these other ones: calcium, magnesium, sulfur, iron, manganese, all these different ones. I don't know how well you can read that, but basically it says the soil provides a lot of these. It says N, P, and K are added through fertilizers, which we know we can add those other ways. But a lot of these others, it says the soil can provide. And that's very true. The soil is rich in these mineral resources. Most of our soils have all of the nutrients that our plants need, but the plants can't get them directly. So what we need to do is we need to hire lots of tiny little miners to go and extract and mine these resources out. This is a picture here of a fungus. This actually came from a mine in China. They found this fungus growing in this mine, and this is highly magnified, but if you can see the little fungal hyphae growing through solid rock, and it's basically extracting iron and magnesium out of this ore. And it's pretty cool that, you know, again, what a plant root could never do that. And man can only do that with, again, extremely large investments in equipment and infrastructure, and then a lot of chemistry to pull that out. Fungus can do that because it is pulling that out, and I'll show you here in a second how it does that. This is another article. This was in Scientific America a few years ago, and I love the title of the article here. It says, "Mycorrhizae fungi run the largest mining operation in the world." Very catchy title. This picture here, the one on the right is a highly magnified piece of feldspar, which just think of it as a tiny grain of sand. And what they've done is with their electron microscopes, they're able to look at this and they can see that these brown lines here are actually voids. And think of it as a mine shaft. Just like that other picture, you saw that fungal hyphae drilling into that solid rock. That's the same thing that's happened here, but it's happened a while ago. The fungus is not here anymore, but it left behind the mine shafts. Fungus is able to generate or produce acids that can dissolve solid rock. And as they dissolve it, they continue to grow in, and they just keep going in and in and in. They dissolve that minerals out, they pull it back out, and so now the fungus, which is kind of a web or this hyphae network, has all of these minerals that it's dissolved out of the feldspar, out of all of the other minerals in your soil. Now it has these, and it can offer them for sale, in essence. And it will, if the plant says, "I need iron," the fungus can say, "Well, I know where to go get that, but I'm not going to give it to you for free. You have to pay me for it. You have to give me carbon." Because as cool as fungus is, and it can excrete acids that will drill through solid rock, as cool as that is, it cannot make its own food, and it has to rely on the plant to make its food for it. So Mycorrhizae fungi, this is what it looks like. The little black dots in there are the arbuscles. They grow actually inside the root, and then the hyphae extend out from there. The author of this article in Scientific America, Jennifer Fraser, It says mycorrhiza mine the soils not only for the basic nutrients needed, like nitrogen, etc., but also for the hard-to-come-by ones, like zinc and copper and manganese, which are critical that plants need these things to be healthy and survive. And she says, oddly enough, I don't think it's odd, it's the way it was created, but oddly enough, many soils are rich in important nutrients, but they're often locked up in a physical form that makes them unavailable to most plants. And when we don't have the biology there to go extract that out, and we start seeing deficiencies in our plants, what do? We come in with the welfare program and we rescue the plants because we've eliminated the biology out of the system. Okay, infrastructure. Transportation, communication are the two most important infrastructures that we have. We know these are important because in times of war, when one country's fighting another, one of the most effective wartime strategies is you try to blow up and destroy their communication and their transportation infrastructure. So you bomb the bridges, you try to take out runways, roads, you try to take out any type of communication, because if you can eliminate a country's ability to transport and communicate, you will literally bring their economy to its knees. So as I was thinking about this, transportation infrastructure in the United States, you know, one of the reasons the United States is such a strong economy, and even though sometimes we think our economy is not that great, anytime you think that, you should just go to other countries. Because even at the worst of our economic times, we're far better off than most other countries at the best of their times. One of the reasons that we're so strong is because of our transportation infrastructure. And if you look here, this is the interstate highway system. These are large roads that can efficiently and quickly transport goods and services across the country. And it's a great network across the country, but there are a lot of areas that are not real close. Like we're right down here, we're about 50 miles from Interstate 80, and we're about 80 or 90 miles from Interstate 70, so we're kind of down here. We're not super close to an interstate. And there's other areas that aren't real close to an interstate, so it's more difficult for us to get our goods and services to an interstate. And so as I started thinking about this, I thought, well, but we have highways. They're not quite as big a roads, but they're still pretty decent roads. And it can get our goods and products from our area to the interstates where they can go out from there. And as I was looking at this picture and thinking about this, I thought of this picture that I'd seen before. That's exactly what's going on in the soil. A plant root is like the interstate highway system because they're big conduits to transport large amounts of goods and services from the plant, which is the factories that's producing the carbon, and it will transport it down into the soil where it can be spent or traded to the soil organisms. But it's also bringing things up. It's bringing all those minerals up. It's bringing the water that's been stored up. So this is two-way conduit, like the big interstate system. It's very efficient. It can move a lot. But look how much of the soil is not touched by the plant roots. A lot of it. So this is the highway system interposed over it. This is Mycorrhizae Fungi, which grows from the roots out into the soil. And the mycorrhiza can explore a much larger portion of the soil, and it will function as those smaller roads, those smaller conduits, to bring things into the large system. So only when you have both do you have a really efficient, effective transportation infrastructure. Mycorrhiza helps transport all of these different nutrients, and in dry times they can help supply water as well. And a soil system without mycorrhiza is like a farming system without roads, rail lines, or ports. It's got huge potential, but it's severely limited. Several years ago, I was fortunate enough to go with No Till on the Plains to Brazil, kind of on a study tour. And one of the areas that we went to is Mato Grosso, which is this region up here in central Brazil. It's the huge area of Cerrado. And it's where they have these huge soybean fields. And there's farmers that are farming 100,000 acres just of soybeans. And you actually see, pictures, where there's 20 or 30 combines out in the field. They told us just in this area of Brazil, this statistic is shocking to me, but I assume that it's true. They said just in this area of Brazil, there's more land that they could bring into production than what the United States currently is growing in corn and soybeans combined. Okay, that's about 170 million acres of land in this area of Brazil that they aren't farming yet. And these guys are getting 60 to 70 inches of rain and have about a 10-month growing season. So they can grow 2 crops a year. Think of all that land that could be brought into production. Now, their soils are crappy, okay, so it takes a lot of work to get their soils to be productive. But what's really limiting them from really tanking the soybean markets in the world is this. They have almost no transportation infrastructure. That's right in the middle of Brazil, and it's a 3-day trip. A 3-day trip from the farm to the port. Everything goes out through the ports because they don't use a lot of it in country. Most of their livestock is grass-fed. They don't have a large livestock industry to use their soybeans. It's all got to be shipped to the port for export. 3 days with a truck one way, 3 days back. Think what that would do to your harvest if it's a 6-day round trip for every semi-load that you harvest. It really limits what they can do because they're limited in their transportation infrastructure. Now, it's not just the roads, or it's not just the mycorrhiza that is important for transportation infrastructure. Earthworms help transport the water. When you have an earthworm, healthy earthworm population in your soil, you will see soils like this where you have all these little holes, and those are channels that help transport water and oxygen and surface carbon through the residue and other biology as well. Earthworms are kind of the public transit system of the soil, because not only are they opening up these big channels for water and oxygen to exchange, they're also ingesting organisms, and then they'll poop them out in another place, so they're moving them. Sometimes these other biology will jump on the back of an earthworm and get transported to another location. So when you have a soil that is devoid of earthworms, it's going to be very difficult for you to have good infiltration rates. Because that's transportation. It's going to be difficult to have good oxygen exchange, because again, that's transportation. And the rest of your biology is going to suffer if you don't have the worms. When you start getting earthworms and you stop disturbing the soil, you'll start seeing a lot more of this transportation happen. Communication is the other infrastructure that I want to talk briefly about. Plants use liquid carbon root exudates to communicate what they need. Because if you think about it, I've talked a lot about the plants are using this carbon to purchase services from the biology. But how does the biology know what the plant wants? How do they communicate that? And the way that they do that is that they will exude a different carbon compound. Remember I said carbon can form over 10 million compounds. It exudes different compounds based on what it wants. So if it's wanting boron, it's going to send out a different chemical compound than if it's wanting iron, or if it's wanting nitrogen, or if it's wanting phosphorus. So it will use different carbon compounds to signal to the biology what it's wanting. So that's one way that communication is going on in the soil, is by these different carbon compounds that the plants send out. And that area right around the roots is kind of like a little Chicago Board of Trade. If you've ever seen the Chicago Board of Trade in action, it just looks like complete chaos. But people are buying and selling. There's commerce going on. And that's exactly what's happening right at the root tip, is that there's buying and selling going on, and the plant is saying, hey, I need this, I'm willing to pay this, and it gets together with the biology, and the biology is able to provide what the plant needs. So it's where commerce is happening. Also in communication, there's been a lot of cool studies, and this is an area that I'm fascinated with. I don't pretend to understand it really well. But plants can communicate with each other in two main ways. One way is when you have a healthy mycorrhiza population, it will actually tie the root system of plants together. Now, I had a microbiologist tell me once that plant roots won't actually physically touch each other, especially plants of different types won't touch each other. They'll come very close, but they won't actually physically touch in the soil. The mycorrhiza can grow from one plant, and it can extend out and then grow into another plant. So it essentially becomes the conduit that links the whole system together. And then plants can use that, and they can send out warnings, they can send out defense signals from one plant to another, if this plant's under attack by aphids, it will send out a compound that travels through the fungus. This plant picks up on it, and it starts ramping up its defenses to help protect against an aphid infestation. And what they've discovered is that it works two ways. It works through the plant roots, can be tied together, but it also can work through volatile chemical compounds that the leaves will produce and the other plants can actually sense. So it's got two ways of working, and they've done all kinds of experiments where they've eliminated this and it still works, or they eliminate this and it still works. So plants can communicate with each other not only through these chemical compounds or the carbon compounds through the soil, but also through volatile chemical compounds that essentially they can smell. So if you're interested in this kind of stuff, it's fascinating. Jack Schultz, Dr. Jack Schultz from the University of Missouri, has a really good TED Talk that's on YouTube. If you just search for Dr. Jack Schultz, University of Missouri, he has a good talk on how plants communicate. There was an article in the Scientist magazine here that called Plant Talk. It says plants communicate and interact with each other both above ground and below in surprisingly subtle and sophisticated ways. And it says that plants can communicate with insects as well. They can send signals to insects that will bring in the beneficial insects. If a plant knows that it's getting attacked by aphids, it'll send out a signal and it can bring in the predatory type insects. And the thing is, that signal doesn't travel a long distance, so you have to have some predators somewhat close by. So later on, Jimmy Emmons will be talking about some work he's done with some pollinator strips trying to get those predatory insects close by, so when the plant sends out the signal that, hey, I'm under attack, there's actually somebody there to catch that signal and listen. Because you can scream for help all you want. If nobody's there to listen, it doesn't do you any good. And so plants have the ability to call for help. We need to create the environments that we have the guys there that can come to their rescue. Okay, defense and protection is the last area that I want to talk about in the economy, and then we'll kind of summarize here. Again, you need to defend your economy because there are always going to be those who want to consume without producing. And you see that with parasites, you see that with diseases, you see that with all sorts of things. So there's any number of things that our system has to be protected from. You know, number one is water. We have to have water to make our system work, but we have to protect our system from the water because too much or too little will wreck the whole thing. And so you've all seen pictures of the destructive impact of a raindrop. We have to protect against wind. You've all seen pictures of the Dust Bowl. We have to protect against these and heat and cold and compaction and weeds and insects and diseases. There's any number of things that can wreck the whole system that we've worked so hard to make. And so there are several lines of defense. Number one is we need to keep the soil covered. If you don't have the soil covered, nothing else that you do is really going to work. So Rolf Derpsch, who was actually our tour guide when we went to Brazil, he says almost all advantages of the no-till system come from the permanent cover of the soil, and only a few come from not tilling the soil. So the advantage of no-till is not so much in the not doing the physical act of soil destruction, which that is important, but he's saying keeping the soil covered is even more important. Always aim for full soil cover. And that's so important because none of the other things that we do are going to have lasting effects if we can't keep the soil covered. You'll hear almost every speaker throughout the next 2 days will stress this, and they'll talk about this. Nathan talked out there about that's one of the basic tenets of soil health. You have to keep the soil covered. Number two, there are some natural defenses and protections. We talked about this a little bit when we talked about communication, about how plants signal each other, and that's very true. This is further information from this article from the Scientist magazine, just talking about how plants communicate both through the air and through the root system. But the thing is this system right here is not going to work if you don't have the mycorrhizae. That you lose your entire communication network below ground if you don't have healthy biological systems. It just does not exist. You'll still have the above ground part, but you've lost a big part of your communication and the ability for plants to talk to each other to help them defend each other. A third line of defense is symbiotic relationships between plants and fungus, or plants and organisms, such as this endophyte fungus. think this is actually a picture that I got from some of the guys at the Noble Research Institute. This is one of the plants that they're working on developing novel endophytes. That's a fungus that actually lives in a symbiotic relationship with plant roots. The fungus provides protection, the plant provides the food source or the carbon, and they all live happily ever after. And so there's more and more of these types of things being researched and developed of this whole area of symbiotic relationships. And a fourth line of defense is just simply diversity. If you have a diverse system, it is very unlikely that everything's going to get wiped out by a particular disease or a particular pest. If you have just corn, it's very likely that you're going to get wiped out if you don't do something, because especially if you go corn, 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 corn. And that's a pretty common rotation in our area. Pioneer corn, Syngenta corn. They think that's a rotation. It's really not. The more diverse our rotations are, the less likely we're going to be hit with diseases and pests and these things. Or if we do get hit, it's like Walt Davis said, they're going to be there, but they're going to be, the economic thresholds aren't going to be met because there are other things in the system. The diversity is keeping all of those things at bay. So I can't stress too much about how important that diversity is. For most of us that are crop farmers, it's very difficult to get more diversity within our cash cropping rotation. That's hard to do because it takes specialized knowledge, specialized equipment, and specialized marketing. But with a cover crop, it doesn't take any of those things. You don't have to have special knowledge to plant a cover crop. You don't have to have special equipment. And you certainly don't have to have specialized marketing abilities, because the market for this cover crop is the biology. You've got your market already there. So that's the easiest way to get diversity into your system, is to do cover crops. And when you do a cover crop, you know, for goodness sakes, don't just plant sorghum Sudan and say, I'm doing a cover crop. You know, you can do so much better than that. You can plant, you know, a 4-way, a 5-way, a 6-way mix of things if the time frame allows it. Now, there's sometimes when it gets too late in the season that all you can do is maybe plant cereal rye. But that's still better than nothing. But if you have the opportunity to plant a cover crop, get as much diversity in there as what makes sense. Okay, so there's the keys to a healthy soil. We went through all 7 of those economic principles, and we have applied them to the soil. And I just want to kind of, in summary, kind of quickly go through 9 takeaway points here for you to summarize this. Economies are intricately interconnected and interdependent. You can't change one part of it without affecting the others. And so in this system, it's a very fragile system. When we mess with the biology, which we've done largely through industrial ag, when we mess with the biology, we mess up the other parts of it, and then we have to step in with the welfare. Number 2 is we need to reduce the amount of that welfare that we're having to give our system, because as thin as the margins are in farming right now, you know, one of the best ways to increase our margins, to increase our profitability, is not necessarily to produce more, but it's to spend less to produce what we're producing. And so we need to try to reduce the amount of inputs that we're giving. And the way that we do that is by get everyone working the way it was created to do. Figure out ways that you can bring back the biological component, and that's going to look different for you than it looks for me. So, you know, your challenge is, what does that look like on your farm? How does that work on your farm? But we need to reduce the amount of welfare that we're giving, because welfare is expensive. Number 3, increase your cash flow. Your banker, you know, go into your banker and say, I'm really increasing my cash flow this year, and then hand him a big pile of cover crops. See what he says. He may not find that funny, but you might. Cash flow of your carbon, it needs to be increased. When I tell this to guys up in my area, when you're in a corn-soybean rotation, you're utilizing less than 50% of the solar energy that's hitting your ground. Less than 50%. That energy is free, and we're wasting more than half of it. Look at your own operations. Find the windows of time when you've got nothing green and growing out there, and try to figure out, what can I do to increase the amount of carbon that I'm capturing, the amount of cash flow I can put into my system. And then take that excess carbon, when you increase your cash flow, invest it in these long-term carbons, increase your organic matter levels, and then don't sell off your investments. Because when you come in and you do tillage like this, or you bale up this residue and you haul it off and sell it cheap to a feedlot or something like that, it's like you're selling off the capital investments that you've made. And that's not a good long-term solution to growing your economy. You can't be selling your capital all the time and expect to grow and be healthy. So make those capital investments in your organic matter and then do whatever you can to not have to sell those off. Number 5, solar energy is free. Use every opportunity to capture it and boost your economy. So don't just grow corn, put cover crop rye, and then come back with soybeans, and then come back with a cereal grain, and then a highly diverse cover crop mix, and then graze it with cattle. That's kind of the ultimate solar capturing, cycling system up in my area. And this is, again, what I stress to people up there. It's what we're trying to do. We're not there yet, but we're moving in the right direction. So figure out how you can capture more solar energy in your system. Number 6, take advantage of all the free tiny workers. There's all these things out here that will literally work for food. You give them some carbon, they're going to give you things that are very, very valuable. So take advantage of those things for manufacturing, for mining, for transportation, communication, and protection, and do what you can to increase the amount of biological diversity that you have. And there's ways that you can do that, but the main way is you'll get biological diversity when you have crop diversity above the ground. Number 7, build and do not destroy your infrastructure. You will really see your economy grow. So do what you can to build up the communication and the transportation infrastructures, and then don't come in and do this. Because remember I said that a wartime strategy is trying to destroy the transportation infrastructure of another country. So think about it, when you're disking your ground, you're literally declaring war on your soil. Think about that. Number 8, protect your economy with soil armor. You have to keep it covered, because if you have bare soil, none of these other things that you're doing are really going to have long-lasting effects. You have to keep the soil covered. And then number 9, do I have a number 9, Caleb? I'm froze. Oh, there we go. Diversity is so very important for a healthy economy, plants, roots, and soil animals. Do whatever you can to get more diversity into your system, because that's going to give you the most protection and give you the most resiliency in the system. So there's the 9 takeaway points. I know I covered a lot of information here. Again, this talk will be on YouTube if you want to watch it again later. I appreciate your patience with me on this.